Hello. So today we're going to be talking about Chapter 5. So Chapter 5 is going to be looking at cost, volume, profit analysis. So this chapter is going to really start to look at how we break up our costs into different types of costs. And so up until this point, we've kind of done that to some extent, looking at things like direct materials, direct labor, manufacturing overhead. But we haven't really looked at the underlying structure of each type of cost like we're going to today. So today we're going to be looking at differentiating if something is a fixed cost, if it is a variable cost, or if it is a mixed cost, and what those implications are. Now, the next time we meet, we'll actually get into what is called break-even analysis, and we'll start figuring out, well, how many units do I need to produce to earn a profit of zero? Which is a really important question for businesses to ask, because if I don't know that, then I don't know how much I need to produce to start making a profit. And so that's a really good starting point for a lot of businesses. So what we're going to do today is we're going to kind of lay the groundwork to get us ready for that analysis in our next class. So let's go ahead and get started. So today, we're going to look specifically at how the costs change in response to changes in activity levels. So this equation right here is going to be a very important equation for you in this chapter. We're going to be using it quite a bit. I'm writing with my mouse today, so my handwriting is not too great. I do apologize, but hopefully it'll be good enough for you to be able to tell what I'm doing. So this equation is going to be very important in this chapter. There's several other equations in this chapter we're going to need to know, particularly for the exam. But this is where we want to start, which is our total cost that we incur is made up of two components. The first component is what we call total fixed cost. This means that with, a pretty baseline level here, regardless of how much I produce, and we'll talk about the constraints to that, what we'll eventually see as maybe the relevant range is the term we'll use. But we'll say within this range, my fixed cost does not change, right? If I can produce 10,000 units in my factory, then whether I produce 1 unit or 10,000, my rent does not change. But what might change is the amount of materials I need to produce 10,000 units versus the amount of materials I need to produce 1 unit. So in that example, the rent for the factory is not changing anywhere from the first unit of production through the 10,000th, making that a fixed cost. But now, if I needed to produce 20,000 units, I might need to rent a second factory, or I might need to expand my operations, which might require a larger factory, which then might bump my fixed costs up a whole nother level. Alternatively, we can see that the materials required to produce 1 singular unit will vary dramatically in total from the materials needed to produce 10,000 units. So what we'll notice about our variable costs is that at their most fundamental level, they differ in total, but they do not differ per unit. Alternatively, our fixed costs will be fixed in total, but will differ per unit. Now, that's a lot to kind of take in for the first time right here at the beginning. So I just kind of wanted to throw that out there, and then we'll see that as we go through the next slides, and we'll kind of understand exactly what all just got said. So if that felt like a lot right now, don't worry too much. We'll kind of keep explaining that as we go. So here we go. In this case, so I need to delete the annotations real quick from the last slide. They ask us, they say, assume we have direct materials that cost $50,000 to make 5,000 units. And they want to know what it would cost to make 1,000 units or to make 10 units. So this right here, where we know the cost for a specific level of production, is what we call a fixed budget. Now, in general, fixed budgets are not that helpful for us, because if my plan and what actually happen to differ, then the fixed budget is pretty useless when it comes to actually determining if we did good or not that period. For example, if I tell you it cost me $60,000 this period for my direct materials, and you said, well, it's only supposed to take you 50,000, you say, well, you did a bad job. But I say, well, I produced 10,000 units. And you go, oh, well, okay, maybe you did a good job. So what we notice here is that with a fixed budget, though, I can actually begin to prepare what we call a flexible budget, which means I can take the portions of my budget that are going to change based on changes in units and get a per unit amount then multiply that out across some other level of production. In this case, they say, if it costs me 50,000 to make 5,000 units, can we figure out how much it would cost us to make 1,000 units or 10 units? So in this case, we're going to start by taking my total direct materials cost divided by my total units of production. So in this case, that will be $50,000 divided by 5,000 units. This comes out to be $10 per unit. $10 per unit. And now they say, well, if we're making 1,000 units, what is that going to be? So I'll take $10 per unit that we just solved times 1,000 units, and I'll get $10,000. So that's how much it would cost me to produce 1,000 units. Well, now what if we wanted to just make 10? Well, I can take $10 per unit times 10 units, and I'll get that this is going to cost me $100. Now, as I mentioned in class, it's very important in this class in particular to always write down those units, right? In this case, we want to make sure we keep the dollar signs on the dollar amounts and identify the units or the miles or whatever that is on the bottom. That way we can make sure our answers make sense. If we don't keep track of those, then it's very likely that we'll end up making a mistake. And so it's really important that we take care to not make those mistakes, and that's how we're going to do it. Now, let's see if we can figure out a way to erase everything on the slide at once. There we go. All right. So next we're going to go in and we're going to do a similar thing, but we're going to do it for direct labor. So now they tell us, assume it takes $75,000 of direct labor to make 5,000 units. Well, in this case, we're going to say, all right, let's take 75,000 divided by 5,000 units. When you do that, that comes out to be $15 per unit. So 15 per unit. And now we just need to multiply things out. So we'll take $15 per unit times 1,000 units. This gives us a total cost of $15,000. Now, being able to do this type of adjustment is a really powerful thing for us because it allows us to make meaningful comparisons between different activity levels. Otherwise, if I only know that it costs $75,000 at 5,000 units, and for whatever reason, my actual production maybe differs dramatically from what I might have expected at the beginning of the period, then if I just take straight subtractions without accounting for the difference in the units produced, then I can make some really poor judgment decisions about how well or how poorly we did that period. And so remembering that we can always take a fixed budget and turn it into a flexible budget is a really important skill for us. Now, the next thing we're going to do is we're going to take our $15 per unit times 10 units, and we'll see that this comes out to be $150 in total. We'll go ahead and move to the next slide, and we'll clear out the drawings from this one. All right. Now, the two that we looked at just a minute ago, direct materials and direct labor, both vary in direct proportion to the amount of production we need, which means as I produce more units or less units, my total cost will change. However, in this case, we're looking at a manager's salary. Well, a manager's salary is fixed, meaning it does not matter what the production level is, the salary will be the same. Other good examples of this might be depreciation under certain methods. It might be factory rent or insurance. There's plenty of costs that are fixed, and it doesn't matter if you produce 1 unit or 10,000 units, right? As long as you're in that range, then you're not going to have any issues with the total. But what that also means is that my cost per unit will start to decline. So what we'll see here, I'll just draw a quick graph for this one, and we'll get to the graphs officially later. But I think it's really helpful on the front end just to kind of see this happen. So I'm going to come here, I'm going to draw us a table, and we're going to have the total cost. So this will be total cost. This will be our units, and this will be our cost per unit. Now, let's make the numbers nice and easy, right? We're not going to deal with the question, the the numbers in this question necessarily, they're fairly large and it's hard for me to write with a mouse. So I'm just gonna say, let's take a total cost of $100 as my fixed cost. Draw a $1 sign. And let's say I only produce 1 unit. Well, you can see that the cost per unit in that case is $100. That's fairly straightforward. Well, now, if I produce a second unit, my total cost will not change because it is fixed. So it stays at 100. But now I only have to cover half of the cost with each unit, which means my cost per unit will now come down to $50. Now, let's extend this further. My total cost is $100, my total fixed cost. And let's say I produce 10 units. Well, now you can see the cost per unit has come down to 10. And if we take this one step further, let's say we've got $100 in cost. We produce 1,000 units. I'm not sure why my mouse is shorting out on me so much. Let's say here we've got 1,000 units. I can do 1K because it's hard for me to write zeros. Then we can see that this comes out to be only 10 cents per unit. Now, this is the power of scaling your production. This is what we call economies of scale. And so as I'm able to ramp up my production to extreme levels, my fixed cost per unit will become marginal. And so what we'll actually notice is if we draw this graph and we say here, this is my total cost on the y-axis, and this is my production on the x-axis, all right, my number of units, then my graph will look something like this. If this is 1, and let's say this is 1,000, so obviously this is not drawn to scale, but it will look something like this, where we'll start to come down and notice that at extreme production levels, my fixed cost becomes actually asymptotic with my x-axis. You say, whoa, been a while since I had algebra. What does that mean? That effectively means that the cost is negligible. It becomes almost zero when I get way out to those extreme production levels. This is why if you look at certain industries, for example, the auto industry, there's only a handful of manufacturers. Probably the newest one is Tesla, but even they struggled and still are to some extent struggling to make a profit because it's very, very, very difficult to break into these high fixed cost industries. So the problem is if I can only produce 100 cars, then I still have to have a lot of the same fixed costs that Ford has to have, that Chevy has to have, that those large manufacturers have. But they're able to spread their fixed cost across tens of thousands or hundreds of thousands or millions of units. So even though their fixed cost is incredibly high, their fixed cost per unit is incredibly low. What this means is that they are then able to either generate a higher profit on each sale, or they can actually lower the cost to consumers. So if you're trying to break into the market, you either have to be able to compete with that and provide such a better quality product that consumers are willing to pay the much higher price because of the much higher price you're incurring, or you have to get to some level of mass production where you can match their economies of scale. Very, very difficult to do, very difficult to survive in that area. This is why in those types of industries, you only have a couple of manufacturers. Whether people like them or not, whether they do a good job or not, it's kind of hard to boot them out. It's kind of hard to push in on that area because you just can't get to that economy of scale like they can. Now, the next thing we do is we're going to actually work out this problem. So it's going to show a very similar thing to what we just did here, but assume the factory manager salary is 100. What is the manager's salary per unit? So we're going to take 100,000 divided by 5,000 units, and we'll get, in this case, $20 per unit. But now, when we produce only 1,000 units, we're going to be taking that $100,000 and we're only able to divide it across 1,000 units, which means now my fixed cost per unit is $100 per unit, much more expensive, right? That's 5 times higher. But now, if I am only able to produce 10 units, then that 100,000 is only able to be divided into 10 units, which means my average cost, my average fixed cost per unit is now going to be $10,000. There we go, $10,000. And so you can see why it's beneficial to push out that extra production. Now, let's think for a second. If you're a factory manager and you've got an option, you can either run one shift of employees and they work from say 8 to 5 or 7 to 4, whatever the normal shift work is. And they work for some normal flat rate, right? You don't have to pay them overtime. You don't have to pay them anything. This is just the normal time that they're working. And then someone comes along and says, hey, we actually could run a second shift, but the variable cost of hiring the people, right? The direct labor cost is going to be, say, 50% higher for the second shift because we've got to pay them more because they're working overnight or some item, right? And you say, well, maybe I don't want to do that, or maybe I do. I don't know. Let's think it through for a second. So what do you think? Would it possibly make sense to run a second shift even if the direct labor cost is significantly higher for the second shift? I'll tell you that it might make sense. Now, this is not always true. You would have to look at your actual cost structure and see. But what you're able to do by running that second shift is increase production so that you're able to spread out your fixed costs over a larger number of units. Particularly if you have a very high fixed cost industry, running multiple shifts of people makes a lot of sense, even if some of those shifts require higher payments. Because by doing so, you can extend out that range that you're able to spread those fixed costs across, pulling down the average fixed cost per unit and making it more affordable for you, and then potentially the end consumer, or being able to generate a higher profit margin. Either case is beneficial for the company. So potentially it's a good decision. That does not mean it is always a good decision, particularly if you have a very low fixed cost industry, then you're just ramping up direct labor for no reason. But if you're in a very heavily manufacturing facility, or you've got a lot of big machinery that's got a lot of fixed costs, you might consider adding on a second, maybe even a third shift to try to extend those fixed costs out over as many units as possible. Okay, very good. Next, we're gonna look at this little chart. This chart is helpful in that it tells you exactly what we've been talking about so far. Now, after this, pretty soon, we're going to get into the graphs and we'll see exactly how this really works out. But that'll be just a little bit further. So in this case, we see that in total, variable costs vary, and in total, fixed costs are fixed. This is why, though, when we talk in this class, I will push you very, very tightly on language. If you just tell me something is variable, I'm going to probably tell you you're wrong because I don't know what you mean. Right? I will play dumb because I want to make sure you are very intentional in the way you say things because it will help you make the connections more clearly in your head. So what we notice here is that when we have a variable cost, it varies in total. You say, why does that language matter so much? Because notice what's right next to it. On per unit basis, variable costs are fixed. This means that variable costs are both variable and fixed, depending on the situation we're talking about. So I encourage you to be very intentional when you talk and say, oh, this is a variable cost in total, or this is fixed in total, or say this varies per unit or is fixed per unit. And it will make you make the connections in your mind a lot more clearly. Next, we look at fixed cost, and we see in this bottom middle box, it says, well, fixed costs are fixed in total, which means, once again, if I produce 1 unit, 10 units, 100 units, 1,000 units, as long as I'm in my relevant range, that fixed cost will not change. However, on a per unit basis, as we saw in the previous slide, this certainly does change. And so as we increase production, the fixed cost per unit will begin to decline quite quickly. It does what we call it decreases at a decreasing rate. So when you go from 1 unit to 2, it's a drop of 50%. When you go from 2 to 3, it's a drop of about 16.7%. And it continues to come down very quickly. But it does slow down over time because it just can't continue dropping that quickly. Okay, so decreases at a decreasing rate is what we say for the fixed cost on a per unit basis. All right. So in this case, variable costs, as we've talked about, these are costs that vary in total, directly and proportionately with changes in the activity level. and unit variable costs will remain the same at every level of activity. Now, you say, Mr. Allen, I don't agree with that. Some companies receive bulk quantity discounts, etc. And I say, you are absolutely right. They do. And we could absolutely implement something like that. But then the math gets significantly harder for us. If we start having nonlinear relationships, then we start having to go to things like calculus to calculate nonlinear things, and that just makes our lives a lot more difficult. So in this class, we're going to make a simplifying assumption that bulk discounts and things, they don't exist. We're not going to be dealing with variable rate pricing and all sorts of things that make our lives a lot more difficult. We're going to keep this nice and simple. Now, in real life, if you need to deal with something like that, you can either use calculus or you can use a series of algebraic steps or whatever you need to get there. But we're not trying to make this class a super heavy math intensive class by giving you a lot of weird things like that. We're going to make some simplifying assumptions and say, look, in this class, we're going to say if it costs you $10 per unit for direct materials for the first unit, it costs you $10 per unit for direct materials for the 1 millionth unit. They all cost the same, and we're not dealing with bulk discounts or anything like that. Okay. Next, we're going to look here and we see an example similar to the one we worked earlier, and we can see how this one works out. So if it costs us $10 in direct materials to make 1 unit, then it will cost us $20,000 to make 2,000 units, $40,000 to make 4,000 units, or $10 to make just 1. But notice the per unit amount is not changing. So if you go back to that table we looked at earlier, you will see that as we said, the direct materials are fixed on a per unit basis, but they change in total, meaning they are in fact a variable cost. Next, we look at direct labor, and we'll see something very, very similar. In this case, it costs us $20 to use one or to make 1 unit in direct labor. So in this case, 2,000 units times $20 per unit is $40,000 in total, giving us a total cost per unit of $20. Then for 1,000 units, in total is 20,000, but per unit remains 20. And we see the same for 100 units. Once again, driving home that point that variable costs vary in total, but are fixed per unit. Very important idea for us to really understand in this chapter. So once again, we're going to go ahead. We're going to fill out this chart. So I'll give you a couple of seconds before I go over it. In case you want to pause the video, try to fill this out on your own. I'd tell you maybe take 5 or 10 seconds, fill this thing out, and then we'll talk about it. So give me just a second. Here we go. So in this case, as we said, variable costs vary in total. Fixed costs are fixed in total, but variable costs are fixed per unit, and fixed costs vary per unit. Very good. So hopefully you got that right, and hopefully you're feeling pretty good so far. Now, these are 4 really important graphs that we're going to start to talk about. We're going to show visual representations of each one of these cost relationships that we've talked about so far. So in this case, we have a company called Damon Company, and they manufacture cell phones that contain a $10 camera. They say on the bottom, on the x-axis, we're showing the number of phones produced. And on the y-axis, we're showing the cost in thousands. And you can see here that when I produce 2,000 cell phones, my cost for variable costs is $20,000. And when I produce 8,000 cell phones, my cost is $80,000. This is a directly linear relationship that varies in direct proportion to changes in activity level. Meaning, when I go from, say, 2,000 units to 4,000 units, a 100% increase, my cost increases by 100%. That is a linear proportional relationship. Something else you'll notice about variable costs is what is the intercept for a variable cost? In other words, if I produce nothing, what is my variable cost in total? Well, if I produce nothing and I only pay for what I produce, then for my variable cost, the intercept is 0, telling me that it is possible to spend nothing on variable costs by simply cutting production down to 0. Now, why is that so important? Well, when we look at fixed cost in a little bit, what we'll notice is that that is not the case for a fixed cost. Whether you produce nothing or you produce at maximum capacity, it makes no difference. the amount of cost that you will pay as a fixed cost is the same. And so it is very important, once again, to understand that with a variable cost, it runs through 0, 0, 0 units, 0 cost. But when you look at total fixed cost, that is not the same relation. So there we go. There's that. Now, this graph, very, very important. We'll likely go over this the next time I see you in class because I'm a very visual learner and I like the graphs a lot. So I would even recommend that when you're getting ready to take your exam, when you sit down in the testing center and you have your scratch paper, there's a couple of things I would do. I would draw my factory overhead T account. I would draw my 4 cost relational graphs here, and I would write down all of my break even, my contribution margin formulas, et cetera, that we'll talk about here in just a little bit. But those are things I would do so that I'm keeping myself in line from the very beginning and I prevent myself from getting confused later. Because I'll tell you right now, when you come into an accounting exam, your brain is much more fresh in the first 5 to 10 minutes than it is 65 minutes down the line when you start going, oh my goodness, what was that formula? What was that picture? What was that? I don't know. It's very hard at that point to pull these things out. But if you'll take a couple of minutes, maybe the first 5 minutes of your exam, and write down everything on your scratch paper that you want to know, then it will keep you from making those mistakes and keep you from getting as worn out later in the test. Because all throughout the test, then you can go back to that scratch paper that you set up in the first couple minutes. A lot of times students tell me, oh, I would do that, but it's such a waste of time. And I will tell you, it is not at all a waste of time. This is the strategy I used on all of my exams in undergraduate and in my graduate degree and on the CPA exam. If you take a few minutes and get organized at the beginning, you will never end up regretting it because it is a very good use of time. You would rather spend the 5 minutes there than have an extra 5 minutes and be cluttered and disorganized later. Okay, sorry for the kind of sidetrack there, but we'll get back on here. So total variable costs vary in total. But now let's look at the unit variable cost. So you'll notice in the total, we see a uniform slope, meaning that the cost per unit is not changing, which is exactly what we see here. And so you'll notice that from the very first unit I buy to the very last unit I buy, my variable cost is always $10. It's a perfectly flat line over that range. And there we have it. So unit variable costs fixed per unit, but total variable costs vary in total. Okay, very good. So here are the two graphs side by side. I strongly recommend you commit these two graphs and the next two graphs to memory, and that you feel very comfortable with what they are telling you about the cost. Because there's many ways I will figure out if you understand these relationships, both on the homework, on the adaptive practice, on the exam, because this is so foundational to what we are going to do, not only on this exam, but for the rest of the course. I know I say things like that a lot, but it's because this class really does build on itself, maybe even more so than financial. And so it's very important that you do not get behind early in the semester. If you start to feel lost, you have to reach out early because that is the only way you're going to survive. If you let yourself get really far behind, we can try to get you caught up, but it's going to be a lot more effort on your part and on our part than if you come to us early and we can fix a few minor things and then get you back on track. So that's where we're at. Okay, next we're going to look at fixed costs. So these are costs that remain the same, notice in total, regardless of activity level within what we called earlier the relevant range. Once again, if my factory can only produce 10,000 units, then the rent on that factory, for example, will not change, whether I produce no units, 1 unit, or 10,000 units. But what will change is if I want to produce 15,000 units or 20,000 units, now maybe I need a second factory, or I need to expand my current factory. I need to get more machinery, more square footage, whatever it is. And so then those fixed costs will actually bump up to some new level where they'll stay until we hit a new limit, and then they'll bump up again. So in this case, they say unit costs vary inversely with activity. As volume increases, unit cost declines and vice versa. And you say, well, that sounds terribly written. And I'm not going to disagree with you. While everything that says is perfectly true, it's written in kind of an academic way. And so what we're going to see here is that what this is really telling me is as I produce more units, my total fixed cost per unit will actually begin to decline. And that's all we need to know, is that I can lower my fixed cost per unit by producing more units. And so if you want to learn it with this verbiage, that's fine. That's totally fine. But I'm more interested that you just understand the logic of what's happening. If I only have one unit, that unit must cover all of my fixed costs. If I have 1,000,000 units, then each unit only has to cover 1/1,000,000th of my total fixed cost. And so we can see that actually starts to come down quite quickly. And once again, this is what we call economies of scale. Okay, examples here: property taxes, insurance, rent, salaries, and depreciation on buildings and equipment. I will tell you there is kind of an asterisk on this one. This is true unless you use what we call activity-based depreciation. If I use activity-based depreciation, then the depreciation changes in direct proportion to changes in production, in which case it becomes a variable cost. Or I might do some kind of other depreciation method where this potentially becomes a mixed cost. There are many depreciation methods, not just the ones you learned about in financial. There are many more. But depending on the method, let's say I'm using straight line depreciation, then that depreciation is certainly a fixed cost because it is not changing with regard to changes in activity level. It's just the same. But if I'm using a depreciation method that does change with changes in production, then I have to be careful, and then I would need to treat this as a variable cost. Now, in this class, I don't think we're going to deal too often with depreciation methods other than straight line. We might deal with them toward the end of the semester once or twice just to kind of remind you. We may not. It just kind of depends on how the semester is going and what we get to. But that's the idea. Okay, very good. So in this case, we have the factory manager's salary is $150,000. And we see here that in total, that will not change. It is always $150,000. But as my production changes, that amount per unit certainly changes. So when I'm producing 2,000 units, I'm only paying the manager $75 per unit. But when I'm producing 1,000 units, then I'm paying the manager $150. And when I only produce 100 units, I'm paying them $1,500 per unit. So you can see very quickly, once again, that there's a benefit to being able to produce more items because it pulls down that total fixed cost per unit. Now, here's graph number 3 that you're going to want to pay attention to. Damon Company leases its facilities. Rent is $10,000 a month. But notice, regardless of my production level, my fixed cost in total, in this case rent, is not changing. Another key point, similar to what I talked about on the variable cost in total graph, is notice where we intersect the y-axis. It is not at 0. In this case, it intersects at the fixed cost, meaning when I look at a total cost graph, the distance that I am above 0, 0 will show me what I actually have as my fixed cost. Then if I had some line at this point, some slope at this point, that would tell me that the sloped portion represents the variable cost of production, while this area under here would represent the fixed cost of production. And so that's what we'll see when we get to our total cost graph. But in this case, my total fixed cost, very easy graph, just flat, straight line. Because whether I produce 0 units or maximum production within the relevant range, my total fixed cost will not change. Very good. But here's the graph we talked about earlier. When we get to fixed cost on a per unit basis, they begin to decline and decline quite quickly. You'll notice that if I have $10,000 in fixed cost and I only produce 2,000 units, then the fixed cost per unit is $5. But by producing 10,000 units, I'm able to cut that down to $1. And so very, very quickly, that fixed cost per unit starts to decline. Okay. Here's graphs 3 and 4. Make sure you know these. I will find some way to find out if you understand these graphs, whether I ask you to label them on the test or I ask you questions that deal with the logic of these graphs. These graphs will, in one way or another, be a key item on the exam, and you want to know these very, very well. Okay. Now, here's the relevant range. So you'll notice the relevant range is the range of activity we expect to operate in during a year. Anything outside of that is irrelevant. That's why we call this the relevant range. This is the portion we care about. This is what we want to focus on. And so this is the idea. Now, when we move from an activity level of 40% to 80%, you'll notice my variable costs begin to increase because I'm producing more. But as long as I'm in this same relevant range, my fixed costs in total will not change. But if for some reason I needed to push to a higher production level, maybe I've got another factory supervisor I could bring in to oversee a night shift. Well, in that case, their salary is going to be fixed. So going from maybe 80% production to 100% production, this difference could actually represent the salary of an additional night supervisor. Now they're able to supervise from 80% to 100%. And so as long as I'm in that range, I don't need to step up again, right? So this is what we call a step fixed cost. So if you ever hear anyone talk about, oh, it's a step fixed, what they're saying is, oh, there's different levels of production here. If I stay in this portion of the map, of the line right here, then what I'll see is a very minor flat cost. But if I want to push up to a new production level, it will not be a gradual increase. It will be a jump. It will be a step up. So I will move immediately from this point to here. Notice there is no line connecting these. That is because there is not a slope here. It is a direct movement. It is a non-continuous function. I do not gradually make the change. I jump from one position of cost to another if necessary. And so that's the thing we have to remember is when we look at fixed costs within each range, they will be fixed in total. But if I need to go outside that range, the total fixed cost may change. But then it will become fixed again for some new range. Okay, very good. Next, we look at mixed cost. So mixed cost or total cost, because the graphs look so similar, is what we're going to talk about here. So notice there's some portion of the graph from here to here where there is no slope. We just begin at that point. That means this distance right here shows me my fixed cost component. Because whether I produce nothing or I produce a ton, that portion is not changing. That is my fixed cost line and my fixed cost component. Very good. But now I do have a slope. This slope of this red line begins to show me that my costs change in total as my production or as my usage changes in total. Well, that sounds an awful lot like a variable cost. As I produce more, the cost increases. As I produce less, the cost decreases. And what we see is the variable component has a total cost of 0 when 0 units are produced. So that is very clearly a variable costing line. And so what we'll say is that at any point on this line, I can figure out the total cost. Because what I'll do is I'll say, well, to get my total cost, once again, from the very first slide of this, I'll say I need my total fixed cost plus my total variable costs. And to do that, I'll remember that total cost can be rewritten as total fixed costs plus total variable cost per unit times number of units. And I'm using parentheses and brackets here, not because they're necessary. Order of operations would take care of this on its own, but I think it makes it a little bit easier for you to visually see the groupings. So hopefully it'll eliminate any potential confusion. But in this case, that's all we would need to do is we would say, well, okay, if I wanted to produce 50 or go 50 miles, then I would come up to this point. Well, I would pull that $50. Then whatever the slope of this line is, I would take times 50, and that would tell me the point on my graph. So that's what we're going for. This red line is my total cost line because it incorporates both the fixed component and the variable component. The slope of the total cost line is my variable cost per unit. Okay. So in other words, this, if you think back to say algebra 1, we learned that the slope of a line is y equals mx plus b. And we said that in this case, Y will be total cost, M will be the total variable cost per unit, times X in this case is the number of units, plus B, that's my fixed cost, my total fixed cost. So if you like, your old time algebra, then you can still use that. That's totally fine. That's all we're seeing here is Y, my total cost, is equal to two things. A variable cost per unit times the number of units plus the total fixed cost, and that's it. Okay, very good. With that, we'll go ahead, we'll clear off the drawings. I'll give it just a second in case you're still writing. You can pause the video. There we go. All right, moving on. So these mixed costs are, once again, costs that have a variable and a fixed component, and they change in total, but not proportionally with changes in activity level. Notice when we go from 50 units to 100 units, my cost goes from, let's say, $70-ish to, let's say, about $100. That's not double. And it's not doubling anymore like it did earlier when we were dealing with pure variable costs because there's a fixed component that is not changing. It is only the variable component driving the change. Okay, with that in mind, let's look at these and see if we can figure out what these are. So are these fixed, variable, or mixed? So what I'm going to do is just out here in the margin as we talk about them, I'm going to put either a V, an F, or an M. It's V for variable, F for fixed, and M for mixed. And you say, well, how am I going to determine this? Well, what do we know about cost behavior? If I've got a variable cost, then it should vary in direct proportion to changes in activity level. If I've got a fixed cost, there should be no change. And if I've got a mixed cost, it should change, but not proportionally. And so I'll stop for about 3 or 4 seconds, give you a couple of seconds if you want to pause the video, try this on your own, and then I'll talk about it and we'll go over the solution. Okay, so in this case, we see that we've got 10,000 units and 20,000 units. So the first thing I'm going to do is I'm going to say, all right, the relationship there is I'm taking this first column, multiplying it by 2, and that's giving me the other column. Which means if that holds true, then I've got a fixed cost. Or I'm sorry, I've got a variable cost. If that does not hold true at all, if it's the same number in both columns, I've got a fixed cost. And if it's not quite double, but it's not the same, then I've got a mixed cost. So here we go. For direct materials, it costs me $20,000 to make 10,000 units. That would be $2 per unit. Times 20,000 units would be 40,000. So that means this right here is a variable cost. We'll put that a little bit closer. There we go. Now, maintenance. For 10,000 units, it's $8,000. But for 20,000 units, it's only 10. Well, is 10 the same as 8? No, so it's not a fixed cost. And is 10 double 8, right? We doubled production. Is 10 twice $8,000? I don't think so. It's some portion more, but it's not double. So in that case, we will call this a mixed cost, meaning there's some maintenance, maybe preventative maintenance that we do regardless. And there's some portion of maintenance that we do on an as-needed basis. So maybe we're in there, we're oiling stuff up, we're greasing it up, we're getting it ready, we're tightening the nuts and the bolts, we're making sure things are running appropriately. But then when something actually goes wrong, we've got to bring someone in to actually fix that thing. Well, that portion is variable. That's going to happen more often as we produce more units. But the preventative stuff, maybe every 3 months or every 6 months or every month, we do X, Y, and Z. Those things are not changing. Those things are fixed. So this has a fixed component and a variable component, making it mixed. Now, for direct labor, once again, we see 17 to 34. Well, that is a direct doubling, so this is variable. Indirect materials, the same thing. 1,000 to 2,000 is variable. But depreciation is the same. Well, if it's the same, regardless of production level, that is going to be a fixed cost. I'm sorry these are not lining up very well. It's driving me nuts, but I don't know how to fix it, so we're just going to all have to deal with it. Next, we look at utilities. 3,000 to 5,000. It is more, but it is not double, right? Double would be 6,000. That makes this mixed. Now, utilities is a very common mixed cost because whether you use any utilities or not, you will still get a utility bill. So for example, if you are fortunate enough to maybe go on a month-long vacation somewhere and you leave on the 1st and you come back on the 1st of the next month, what you'll find is you will still have to pay a utility bill even if you turned off all of your utilities, because there is some fixed component to your bill that they charge you regardless. And that's to support the idea that, well, you could have used the utilities for this period of time. You had the infrastructure, we ran the cords, we ran the wires, we ran the stuff to you. Whether you chose to or not really what they're concerned about at that point. Then, based on your usage, they're going to increase the cost. And so utilities often are a mixed cost in practice, and they're often a good example of a mixed cost in textbooks. And then rent, of course, $6,000 for 10,000 units, $6,000 for 20,000 units makes this a fixed cost. And so if you go on to the next slide, they give you a solution also, but it's very hard to look at. I don't like it. And so that's why I did what I did a second ago on the other slide. So hopefully it'll be a little bit easier for you to look at. But in any case, there's our types of costs. So something like this, I think, is a good exercise to just understand and see, do you kind of get what we're doing so far? Do you understand why these things are important? And then later in the course, we'll actually begin preparing full-blown budgets. We'll begin preparing flexible budgets, doing variance analysis with these budgets. And it'll all become very important at that point that you really have mastered this stuff. And so sometimes I think this chapter can get a little in the weeds, can get a little maybe less exciting than other stuff. And that's fair. But you have to understand how all of this works in this chapter because it sets up so many important topics later in the course. Okay, moving on. The next thing we want to talk about is what's called the high-low method. Now, what's good about the high-low method is it's easy. But normally when things are easy, they're not always the best. And so what we notice is we'll talk about the high-low method, and it's fairly straightforward as far as cost estimation goes. But in practice, it's going to be, let's say, less than ideal. There are more sophisticated methods that can be used. We'll see if we talk about some of those later in the course. Potentially, in my opinion, probably the best way we can do this in practice is with what's called regression estimation. It uses quite a bit of statistics and quite a bit of analysis and data entry to figure out exactly what's happening, what's causing what, and it will produce a much tighter estimate for you. But that's kind of difficult for a lot of people, particularly if you don't have any advanced statistics training or you don't have any real math knowledge and background. The high-low method can be done pretty easily by hand, whereas a lot of times to do some form of regression analysis is going to require some kind of computing system for a company, right? We could do a simple regression problem by hand, but it would not be able to be done in practice for, say, Walmart or for some large manufacturer, like, say, Abbott Pharmaceuticals. They're not going to be doing that by hand. They're going to be using some type of sophisticated computer software to make those estimations for them. All right. So in this case, the high-low method is going to be used to classify mixed costs into fixed and variable components. What this means is I can give you a total cost and some total number of units for every month of production. Then you know, based on what we've talked about, that total cost is going to be made up of at least two components, right? Depending on how you write the equation, maybe there's three. But in general, we're going to say that total cost is made up of two components, a fixed component and a variable component. So how do you discern how much is each? Well, that's what we're going to talk about next. So in this case, they're going to kind of outline the broad steps here. First, find the highest and lowest months. Now, notice there's a word that I skipped. I skipped it because I wanted you to say, hey, you skipped a word, right? I wanted you to notice that because that word is very, very important here. It's activity, meaning when I am making the determination of what is my high month, what is my low month, that determination is based solely on production level or material usage or labor usage or whatever it is. But it is based on X, right? On what is on the X axis. It is not based on cost. Very, very often, it won't make a difference. The highest cost month will be the highest activity month, and the lowest cost month will be the lowest activity month. But I am not above giving you a situation where that is not the case. And the highest cost month is not the highest activity month, and the lowest cost month is not the lowest activity month. Meaning if you decide this based on cost, you will miss the question. Because the argument we are making, always keep that in your head, is X causes Y. Production causes cost, not cost causes production, right? Which means when we make this determination, we make it based on the activity level being done, not based on the cost incurred. Very good. Now, you'll take the difference, you'll calculate a variable cost per unit, and you'll plug everything in. So let's see how this works in practice. We've got an example here on the next slide. So here we go. In this case, they tell us Metro Transit has the following maintenance costs and mileage for its fleet of buses during a 6-month period. So we can see from January to June. And they ask us to use the high-low method to calculate our variable cost per unit and our total fixed cost. And then we're going to write the total cost equation. So in this case, the first thing I have to do is compute my variable cost per unit. So in this example, they've actually already highlighted for us the high and low months. And in this cost, and in this case, you'll notice that January has the lowest miles driven and also the lowest cost. And April has the highest miles driven and also the highest cost. So regardless of how you determined it in this case, you would actually get the right answer. But notice how close June is on total cost to overtaking April. So let's say, for example, if that total cost for June was $65,000, you would get a very different answer than if you picked correctly April because it has the highest usage. Okay, so in this case, what we're going to do, we're going to start by calculating our numerator. So we're going to do the top part of that equation, which is the total cost at the high activity level. So that's going to be $63,000 minus the total cost at the low activity level, $30,000. This comes out to be $33,000. Next, we're going to do the math on the bottom. 50,000 miles minus 20,000 miles. This will give us 30,000 miles. Now, that's not where we stop though, right? We have the numerator, we have the denominator, but now we need to do the actual division. So I'm going to take $33,000 divided by 30,000 miles, and I'll get $1.10 per mile. Meaning that my variable component is $1.10 for each mile. The reason this works is I'm saying I'm taking my total cost and I'm taking the difference in units of production. Well, what that means is if my units of production were the same every month, then my total cost should be the same because my fixed cost and my variable cost would always be the same, but they're not. So what I'm able to do by doing my math like this is discern the portion that's changing because of the change in production level from the portion that is always fixed. Okay, that's the kind of the first 3 steps or so. But now we need to actually write our total cost equation. To do that, we're going to have to do a little bit of algebra here. So I gave you a note here. I said, recall that we just saw this is $1.10 per mile. But we want to estimate the total cost equation. Now, I will tell you, it does not matter if you use the high point or the low point. You will get the same answer, but I strongly encourage you to use both points. It is not uncommon for us to sometimes get working a little bit too quickly, punch something in the calculator a little too fast, and we make a typo. And if you made a typo and you only check one of these points, then you're not going to catch the typo very likely. But if you do both points and you get a consistent answer, then you know that you probably did not make a mistake and things are likely okay. So in this case, first step, I'm going to write out my total cost equation. Total costs equals total fixed costs plus total variable costs. And then we're going to rewrite that to say total cost equals total fixed cost plus total variable cost per unit times number of units. Now, this right here, I'm going to go ahead, once again, I'll put it in parentheses just so it's a little bit easier to read. And now I'm going to say total cost, TC, equals total fixed cost plus, well, we know our total variable cost per unit is $1.10 per, in this case, mile, times, and at the low point, we drove 20,000 miles. So in this case, I'll just plug in what I know. Well, I know total cost is equal at the low point to $30,000. So we'll say this is $30,000 equals TFC plus, and then if we do that math, 1.1 times 20,000, this will be $22,000. Now I do 30,000 minus 22,000 equals total fixed cost, which means $8,000 is equal to my total fixed cost. And now what the power of this is I can take that information and write a total cost equation that looks like this in a more general form. So I can say total cost is equal to $8,000 plus $1.10 times X. And now for any level of activity, I can make an estimation for the total cost I will incur. So in this case, let's make sure this equation works. Well, if I took my total cost equation, I took $8,000 plus 1.10 times 20,000 miles, I would get 8,000 plus 22,000, which in fact does come out to 30,000. Now, we knew it would. I mean, we just reversed the operations we did a minute ago. But the point here is this closes the loop for you. So you can see that this does in fact work. All right. But now I said we could do this for the high point also, because ultimately this should work at either point. If it doesn't, you made a mistake. So now go ahead, take a picture of this, pause it, do whatever you need to here, and make sure you understand what we did at the low point. Now we're going to redo all of this at the high point. So here we go. We're going to move on to the next slide. And we're going to estimate the high point. So once again, we're going to write our equation. Total costs equals total fixed costs plus total variable costs. And you notice I could have just kept this from the previous one, but I think it's important that we rewrite this a lot of times so that we don't forget it. So total cost equals total fixed costs plus total variable costs per unit times the number of units. So in this case, let's go ahead and plug in. Total cost at the high point, $63,000 equals, well, I don't know my total fixed cost yet, plus $1.10 per mile times at the high point, 50,000 miles. Well, if we do this, we get $63,000 equals TFC plus 55,000. So now we solve 63,000 minus 55,000 equals my total fixed cost, which tells me that $8,000 is equal to my total fixed cost. Now, once again, this is the same answer we got at the low point. It should be. If you do both points and you get a discrepancy, let's say at one point you get 8,000, or at one point you get 9,450. There's no way to know which one of those is right. At that point, you have to go back through your math and see where you potentially made a mistake. Because at the way the high-low method is, it says the only reason my cost changes between these 2 months is because my variable cost, or my total variable cost changed. And the only way it changed, since we're holding variable cost per unit constant, is because my activity level changed, which means the math has to work out at both points. Okay, very good. We'll give you just a second to review this, make sure you feel comfortable with it. Pause the video if you don't, go back through it, and then we'll go ahead and move on to the next slide. At this point, I'm going to go ahead and erase everything. We're going to move on. Okay. So now, here's the power. Here's why we care about that. Now I can make decent, say, cost approximations for any level of activity. Because if we go back, you'll notice none of these months have 45,000 miles driven. But now I get a question asking me about 45,000 miles. Well, this would be kind of difficult otherwise. But now I have my equation. So now I know that I can just plug in. My total cost will equal $8,000 plus $1.10 per mile times 45,000 miles. Well, in this case, $1.10 times 45,000. Let's go ahead and do this. Total cost equals $8,000 plus, I believe that's 49,500. Doing that in my head, so you might need to check it, but I believe that's correct. This gives us total cost equals $57,500. Okay, 57,500. And now I can make a cost approximation for any amount. You say, well, now do it for 25,000 or 82,000 or 61,000. I can do that. It's as simple as replacing this number right here with whatever the number of miles is that you're curious about. The high-low method is used pretty commonly in practice, I think, because it's so simple. Now, is it going to give you the most precise approximation? Of course not. You're making a lot of simplifying assumptions by using the high-low method. Will it kill you? Will it throw you into some horrible decision? Probably not, right? It's probably going to be close enough that as long as the conditions haven't fundamentally changed, you're probably okay using something like this. But if you want a better approximation method, there are better approximation methods. And that's why I say, in that case, you might look into using some type of regression estimation. And so for more information on that, any kind of upper level statistics class will probably get into that. Maybe a base level stats class if they get pretty far. But those are the classes you would want to be looking at maybe to go along with this to further your understanding of how you might make even more informed decisions than what we're going to talk about in this class. Okay. Very good. Next. Here's another example. I'll leave it up here just so you have a few seconds to look at it. I'm not necessarily going to write it all out like I did a minute ago. The solution's on the next slide, already typed out and everything. So I'll give you a few seconds. I strongly encourage you, pause the video, work through what we did a minute ago, go through that process and see if you can get this question right, because it is almost certainly going to be on your exam in one form or another, right? You're going to need to do the high-low method in some way, I would expect. And so this is a question that you want to make sure you understand. So there we go. Give you a few seconds. All right. So in this case, the first thing we need to do when we identify that we are being asked to use the high-low method is to do what? So hopefully you just said out loud to yourself or to whoever's in your room, you said, I need to identify the high point and the low point based on what? Now, you've got two options here. You can either say based on, in this case, the units produced or the total cost. Now, which one of these is correct? What is our argument? Always go back there. What is the logic of what we're trying to do? Am I saying that total production causes cost? Or am I saying that cost causes production? Which one is it? And the correct argument is that the number of units produced drives the cost, meaning I identify the high and the low point based on my units produced. So based on this right here. Now, in this case, that would mean that my low point is 7,000, right here is May, and my high point is March, 9,800. And once again, in this case, you would have actually worked out okay. The numbers don't really matter because March also has the highest cost and May also has the lowest cost. So you would have been safe, but you will not always be safe if you make this determination on cost. You make the determination on activity level, on the number of units produced, and you will always identify the appropriate high point and the appropriate low point. Okay, very good. So with that said, I'm going to go ahead and click over to the next slide where you can see the solutions. So once again, May is the low point, March is the high point, and you can see that all they did is what we did before. They took the cost at the high point, 14,740, minus the cost at the low point, 11,100. Then they divided that by the number of units at the high point minus the number of units at the low point. So this is about 3640 divided by 2,800 comes out to be $1.30 per unit. Then they say, all right, now write the cost equation. Cost, so I would say total cost here, once again, to be a little bit more clear in our language. You might make the note that this should really say total cost equals $2,000. Remember, this is representing the total fixed cost component. And then this is representing the total variable cost component, which can be rewritten as variable cost per unit times the number of units produced. Variable cost per unit times the number of units produced. Okay. And when you plug in, so in this case, they said, well, let's figure out the fixed cost. They did 14,740 minus 1.3 times 9,800. And they got $2,000. So they used the high point to figure out the fixed cost component, or they can show you with the low cost component, right? The low point. And so once again, it works out either way. I strongly always recommend that you do both the high point and the low point anytime you get one of these questions. Once you've done a few of them, it doesn't add more than maybe 15 or 20 seconds to your problem, but it makes sure you get it right. And that 15 to 20 seconds to make sure you don't have a typo is absolutely worth it, in my opinion. Very good. All right. Next, they want you to estimate the cost if they produce 8,000 units. So you'll just take that total cost equation and you'll plug in 8,000. And then in this case, you'll get 12,400. And you can see the power of this is none of these produced 8,000 units, but I still have a pretty good estimate of what that cost would actually be. Okay. So here we're going to look specifically at what is called CVP analysis, cost, volume, profit analysis, and it's studying the effect of changes in costs and volume on a company's profits. This leads directly into our break-even analysis that will begin next lecture, right? So this is kind of taking all the stuff we've talked about so far, applying it very precisely, and then leveraging that power into the next lecture. So this is a very important kind of wrap-up component of today's lecture. So hang with me a few more minutes and you'll be good to go, right? All right, so in this case, we're going to look and we're going to see what happens. Now, we're going to produce a different type of income statement in this chapter. We're going to produce what is called a contribution margin or a cost volume profit income statement. What this is going to look like is it's going to be totally different than the income statement you saw in financial accounting, which is prepared under US GAAP. It will not look like that, but it will get you to the same point. It just breaks the costs up in a way that is more useful for internal management than what we have to provide to external users. So once again, CVP or contribution margin income statement is going to be for internal use only. It's going to classify the cost as fixed or variable, and it's going to report contribution margin in the body of the statement. You say, whoa, Mr. Allen, what is contribution margin? You keep using this term, never heard of it before, no idea what it is. Can you help me out here? And I say, sure. Contribution margin represents the amount that we have left of our revenue after we've deducted our variable costs, meaning that in practice, the way we're going to compute contribution margin is we're going to say this is going to be revenue minus variable costs. Now, what did we say about total cost earlier? Total cost is made up of two components, fixed cost and variable cost. We have already controlled for the variable costs here, meaning we're left with only the fixed cost once we get contribution margin. This means the contribution margin is the amount of revenue you have that you can then use to pay your fixed costs, and once those are paid completely, to start generating profit. The contribution margin is the portion of either each individual sale or your total sales, depending on if you're computing this on a per unit basis or in total, that you have once you've covered your variable costs to go towards covering your fixed costs. And then once those are covered and zeroed out, you've covered them. Now, on every unit sale you make, the unit contribution margin goes directly to the bottom line, directly to profit. Of course, you have to take out taxes, but other than that, you're going to go directly to the bottom line. Okay, very good. So, as they say here at the end, this will report the same income as traditional income statement at the end. So now, here's what one of these might actually look like if we were to do this. So they tell us we've got an electronics company who produces cell phone and they have some data. So we can see here the unit selling price per phone is $500. The unit variable cost is $300, so it's just some data for us. And then we've got some fixed costs of $200,000 and we sold 1,600 units. So this is the data for what we're about to be doing. And so you'll notice if I were to ask you at this point, well, what's the contribution margin? what would you say? Well, we've got a unit selling price of $500 and we've got total unit variable costs of $300. So based on the previous slide, I would be telling you that my contribution margin is equal to $500 minus $300, which equals $200. So there's my contribution margin on a per unit basis. So $200, I can't edit it. I should have written there per unit. So if you want to be better than me, write per unit. That way you're very clear and your language is correct. Okay, next. We're going to move on and we're going to see what this actually looks like. So they show you roughly what a GAAP income statement would look like for the same information. It's okay. I have some minor disagreements with it, but it's okay. And they're going to say here the sales minus effectively the cost of goods sold gives you gross profit. Minus your other expenses comes down to gives you net income. It's a very simplified income statement, but it's fine, right? In general, that's what we saw in financial accounting, and that's the general flow of how this works. But notice, we prepare a very different income statement now for the CVP income statement. The only line that's really identical is going to be sales, right? That one's not changing. And then the net income will not change. They will be the same. But everything else is going to be moved around in a slightly different way. Notice when you prepare the GAAP income statement, you start with sales revenue, and the very next line is cost of goods sold. Find cost of goods sold for me on that CVP income statement. I'll give you a few seconds. Give it a quick perusal. Let's see. What do you notice? Cost of goods sold? It's not there. There is no line called cost of goods sold. Oh, okay, I got it. Now go find gross profit on the CVP income statement. Not there, is it? This is because the way we classify the cost is different between the two, meaning there are certain line items that you will only see on a GAAP income statement and not see on a CVP income statement, and certain line items that you will only see on a CVP or a contribution margin income statement that you will not see on a GAAP income statement. So just like we did a second ago, go find me contribution margin on the GAAP income statement. Take a look. Look as long as you want. You're never going to find it. Go find for me total fixed cost on the GAAP income statement. You're never going to find it. It's not there. It's because while they're presenting the same information, the goals are very different. Management cares about how cost behaves, whereas investors really just care about the total costs themselves. I don't necessarily need to know if this is variable or fixed if I'm investing in your company, but if I'm the one running the day-to-day operations, I better know how my costs are behaving. I better know how they work. And so that's what we're looking at here. And so you can see that on the contribution margin of the CVP income statement, Exhibit B here, we start with sales. Then our next line is variable costs. We're going to pull together all those variable costs, getting me total variable costs. Taking the difference gives me total contribution margin. Then I'm going to take my fixed costs. In this case, my manufacturing overhead, my sales salaries, my CEO salary, and that's going to give me my total fixed cost. 320 minus 200 is going to bring me down to income of 120. And so in the end, net income is the same. At the beginning, sales is the same, but everything in the middle changes. So what do you need to know here? You need to know which accounts or which line items are only going to be found on each income statement. So under the GAAP income statement, you're going to see things like cost of goods sold and gross profit that you're not going to see on the CVP income statement. On the CVP income statement, you're going to see things like contribution margin, total variable cost, total fixed cost. Those are things you are not going to see on the GAAP income statement. You need to be very clear about those things because not only could they potentially be test questions about, which line item would appear here or there, or, which would not appear here or there, whatever it is, but they're fundamental to understanding how we get to contribution analysis or break-even analysis next lecture. So it's very important that you understand what the goal is here. And the goal is to better understand our cost structure. By using the CVP income statement, we can more clearly identify how my costs behave. Okay, so we can also do this on a per unit level. And so in this case, if we sold 1,000, we would generate zero net income. So in this case, our sales would be 1,000 units times $500. Our variable costs are $300 total, which is times 1,000 is 300,000. giving us contribution margin of 200,000, fixed cost of 200 results in income of 0. Now, we'll get into preparing this later. This is called a break-even contribution margin income statement, or a break-even CVP income statement. The key thing to remember is when we prepare a break-even, CVP income statement, the net income will always be 0. It has to be, because it's a break-even analysis. We're finding the point at which net income is 0. Now, what that also implies, so that's true, but that has an implication for us that we can use to solve problems. This implies that for a break-even CVP income statement, contribution margin will always equal fixed cost, total fixed cost, because it has to. Because the way I get net income on a CVP income statement is to take contribution margin minus fixed cost. The only way those two numbers subtract to be 0 is if they are the same number. So when I'm doing my CVP break-even analysis, that is something I have to keep at the forefront of my mind, is in the end, what I should find is my contribution margin better equal my total fixed cost. That is the only way for me to get to net income of 0 on the CVP income statement. Otherwise, I can't do it. Okay, very good. I'm gonna go ahead, clear that. And we're gonna look very quickly at a couple of formulas here. So once again, here's our contribution margin on a per unit basis is $200. The very next thing we need to figure out is something called the contribution margin ratio. Well, that just takes my unit contribution margin. So here you could write, like they do, unit contribution margin divided by selling price, or you could just rewrite unit contribution margin and say unit selling price minus unit variable costs. And that's how you compute this component, right? Now, there's nothing wrong with saying it the way they did. That's totally fine. You can just say unit contribution margin, but you might not be given this always. You might just be asked straight for this, which means then you've got to remember how to compute the unit contribution margin. And the way to compute it is to take unit selling price minus unit variable costs. I forgot an open parenthesis, but that's okay. All right. Now, in this question, they're going to ask you, well, what is my unit contribution margin and what is my contribution margin percentage? So here's the information. I'll give you a few seconds, look it over, and then we'll go ahead and move on. Okay. So in this case, the contribution margin per unit is going to be $53, and the contribution margin ratio is going to be $62.35. Now, if we wanted to do the contribution margin income statement, all we would do is we would say, well, this is going to be sales, which is going to be $85 per unit times 4,000 units, whatever that number is. Let's see, 80 times 4 would be 320, be 340,000, I think. And then we would take less our variable cost, which would be $32 times 4,000 units. So that would be 128,000. So that'd be 340 minus 128 would be 212,000. Our fixed cost, so this will give us contribution margin, would be 200, and what did I just say? It'd be 340 minus 12. Let me put this in a calculator real quick. I'm getting confused. I apologize. I should have already done this, but let's just double check my math. I don't want to tell you wrong information. So $85 per unit times 4,000 units is 340. And then 32 times 4 is going to be 128. So 340 minus 128 is in fact going to be $212,000. I think that's what I said before, but then I started getting nervous that I might have made a mistake, and I don't want to give you wrong information. Now we'll take out our fixed costs. Our fixed costs in this case are 190,000, and this will give us net income in this case of $22,000. Okay, very good, $22,000. And that's what we end up with. So the formatting here is not great, admittedly, but that's the process you would go through. If you want to see the more, I guess, ideal formatting, I would look back a few slides right here or right there would be good examples of how you would actually want to format this in practice. But just kind of doing it very quickly here, that's what we end up with. Okay, and that's the end of our lecture for today. So try to watch this at some point, give it a look, but the focus now is not on this, right? The focus now is on getting through the storm that's coming. So if you don't watch this before class next week, no big deal. I'll hit the high points before we dive back in, because we kind of have to do that in these situations. So but right now, focus, stay safe, do what you can. If you're really lagging for entertainment, hopefully this kind of helped you out for a little bit, gave you something to think about. But if you have any questions, don't hesitate, reach out to me. I'd be happy to help. Y'all have a great day, and we'll see you in class.